Right. Good afternoon, good people. Thank you once again for taking the time and the trouble to be part of this lesson this afternoon. This is grade 8 mathematics, which is brought to you by the STEM Digital School, presented by the Africa Team Geeks. And my name is Hendrik Makaneta, and I do hope that we will find a way to navigate this wide range of concepts in relation to the topic of the day. And the group chat is quite active. Let me welcome everyone and to assure you that you can continue to use the group chats or if you have any questions or perhaps if there's anything that you do not understand. But before we can carry on with our lesson, I just want to remind you of the importance of availing your scripts. Remember that we wrote a test sometime back about 2 weeks ago, and I've just put in the email address in the group chat for those who may want to forward those scripts. I see that some of you are new. No problem. We will find a way to ensure that you also do not fall behind. But Simon, I see Simone says you are new in the group. You can also email the same email address just to request the test if you can, and then it can be forwarded to you as well, so that you know what we have done up to so far. So we are now carrying on with our lesson. Thank you very much indeed to everyone. We basically talked about the 3D objects yesterday, and of course we showed in a wide range of ways that when you have a 3D object, you can basically find the number of faces as well as the vertices and the edges of your 3D object. And this we have done yesterday. And today, I just want to show you this 3-dimensional figure, and just to actually demonstrate that if you have the 3D object, this is how you find the different properties of your 3D object. And the first one, you look at the vertices as well as the edges and the faces. So the faces are there. And then of course, we want to carry on just to show that the faces are very important, as well as in as much as the edges and the vertices are also important. And by the way, I have been able to demonstrate without any doubt that whenever you have the hexagonal prism, for instance, the properties of this prism can be clearly defined. And you don't just guess. We don't just guess, but we look at all the faces. And if you look at this prism, known as the hexagonal prism, you can tell that it consists of 2 hexagons. Remember that the hexagon is a 6-sided figure. And this 6-sided figure, there are 2 of those who are now joined together, which are joined together to form a prism. So in this case, we now have something called a hexagonal prism, which has got 8 faces. And how do we determine the 8 faces? You can see that the middle structure now will consist of 6 different phases, and then the bottom phase, and the top face. If you add those together, they should be able to give you 8 faces. And the edges, as I've said, will also be 18. Remember, we've got about 12 vertices, which are found as a result of the 6 bottom angles and the 6 top. And this happens also with the edges. You'll have the 6 in the middle, 6 at the top, and then 6 at the bottom. So basically, those are some of the properties of the prism, which is known as the hexagonal prism. And then the difference between the hexagonal prism and as well as the hexagonal pyramid are very clearly defined. The difference, as you can see, the bottom part of the pyramid consists of a hexagon. So there's no doubt about that. But now the top part, you can see it's quite different, in a sense that the top one has got the edge, and of course, right, just to carry on with the hexagonal pyramid, just to demonstrate that this is different from the hexagonal prism in a sense that the top part is different. You can see that that is a pyramid. All the points, or all the 6 points meet in one point at the top, and it forms your pyramid. So obviously, this will affect the number of faces. So the faces will no longer be 8, but they will now be 7. So the same goes for the edges. You'll have about 12 of those. And the vertices as well. Remember that when we talk about the vertices, we look at the angles as well that are formed. In this case, there will be 7 of those. There will be 6 at the bottom and then 1 at the top. Now, if you add 1 and 6, you get 7. And the same goes for the shape, which is known as the Pentagonal Prism, which now consists of 7 faces. Remember, there will be 5 faces in the middle, and then the top face and the bottom face. So if you add them together, they should give you 7 faces. And then the vertices as well will be 10. So basically, that is what we have. So these are some of the concepts that we are defining. But now within our midst here, we have a 3D object. Why do we call it a 3D object? You can see it consists of, this is a 3-dimension because you have the length, the breadth, and the height. So that's where the 3D or the name 3D comes from, being the 3-dimensional object. Others call it a 3-dimensional shape. Of course, if you put it on a paper, it becomes a shape. Right, can you tell me what kind of a 3D is this? What is the name of this 3D object in our midst? What do we call it? It consists of triangles. You can see that there are 2 triangles, but there are also, okay, Musa has answered that. Now it consists of 2 triangles, as I've said, together with 3 rectangles. Musa says this is a triangular prism. Great. And the triangular prism should not be confused with the triangular pyramid. The triangular pyramid, only the base will be the triangle, but now the top will no longer be a triangle because it will be a pyramid. But in a triangular prism, the base will be the triangle and the top will also be a triangle. So you can see that it is now, this consists of 3 rectangles and 2 triangles. So basically that is what we have. And then of course, we have just demonstrated to you just the importance of this particular activity. And just to recap once again, we spoke about the cube, the rectangular prism, the cylinder, and you can see our triangular prism at the bottom, the yellow and red drawing there. That is our triangular prism, which is much more different from the other one, which is now a pyramid, a triangular pyramid. We are not going to look at a lot of questions today. Before we can even go to the surface area of different 3D objects, I just want us to finalize now the area of the square. This is basically important because there's a link between the 2D shapes as well as the 3D objects. So now I just want us to take the time to calculate the area of the square where the length is 15 centimeters. So basically, we are given the length. And Natalie, I can see you are present today once again. Can we find the area of this particular square? And thereafter, let's look at the perimeter of the square. Let's find the area which has got the length of 15 centimeters. So I hope that everyone has a paper and a pen and that you are busy now calculating the area of the square. It's very important to recall the importance of the area of one square. Why do we do this? Because when it comes to the cube, a time will come when we will have to calculate the surface area of the 3D object, which is known as a cube. So remember, a cube consists of squares there. So those 6 faces are the 6 squares. So basically, when you calculate the area or the surface area of a cube, you will have to look at all the squares. So basically, that is what we will be doing. Let's now finalize. I see Cesar has already given me the answer. And Cesar, I agree with you. That is the correct answer there. But I just want everyone else to demonstrate just 2 more answers from 2 students. I'll be happy. But as we carry on, of course, you will see it says that 225 square centimeters, and you get this when you multiply 15 by 15. So I fully agree with you. 15 multiplied by 15. And this will give you 225 square centimeters. Why 15? Because the length of the square is 15 centimeters. So the length of the square is 15 centimeters. The length of the square is 15 centimeters. Now, that is what we have done in as far as this particular activity is concerned. Can we now proceed to the perimeter? Let's do the perimeter. The perimeter is going to be calculated as well. We know that when we have a square, we can calculate the perimeter. So I see that several learners, Cesar together with Ntlantla, as well as Natalie, you have found the perimeter to be 40 centimeters. So I'm glad that you have been able to find the perimeter there. So basically, yes, when you calculate the perimeter of a square, P is equal to 4 multiplied by the side. So you simply multiply the side. But before we get there, we can just recall as well that the area that you have, you just multiplied the side together with the side. And of course, one of the sides there was 15 centimeters, which was done by Cesar, and Cesar was able to demonstrate that when you multiply the two, you get 225 square centimeters. That was correct. And when it comes to P as well, we should know by now that the perimeter is given by the formula. So there's always a formula. But even if you don't know the formula, it doesn't mean you cannot calculate the perimeter. Remember that the perimeter is known or defined as the distance around the edge of the shape. So if you can be able to travel the distance around the edge of the shape, then you should be able to complete your perimeter. And in this case, one of the other ways to do this is to add the 4 sides. And one of the sides, as we know, is given to be 10. We are told that one of the sides is 10 centimeters. And of course, if you multiply 10 by 4, you will definitely get 40 centimeters, just as everyone said. I'm just saying you don't necessarily need to memorize the formula. You don't have to memorize the formula. You can just carry on to remember that the perimeter is the distance around the edge of the shape. Now, I'm just going to also carry on just to proceed with the next activity of the day, where we must also calculate the area of a triangle whose base is 6 centimeters and the height is 10 centimeters. Can we find such a triangle? The base is 6 centimeters and the height is 10 centimeters. Remember, once again, you need to understand the basic principle when it comes to the area of any triangle. Why do we calculate this? This is because when it comes to the triangular prism, for instance, you may need to calculate the surface area of a triangular prism. And for you to successfully do that, you need to have a background of how to calculate the area of just one triangle. Remember that the triangular prism consists of 2 triangles and 3 rectangles. So if I want to now to calculate the total area or something called the surface area of a rectangular or a triangular prism in this case, then you will need to calculate firstly the area of one of the triangles, and then you can multiply that by 2 because of the 2 triangles, and then you can each rectangle there do the area of every rectangle. But for now, that is the work for another day. But for today, I want to just to calculate the area of the just one triangle. Right, I see Cesar, I've seen your work there. You have written your work as 60 square centimeters. And I just want you to elaborate as well, Cesar, how did you find it? How did you find that 60? Just for the sake of this, for the purpose of this lesson, how did you find 60 square centimeters? Right, I see, Cesar, you are saying that you multiplied 6 by 10 just to get 60 there. Right, I think I just want to take you back to just the area of a rectangle. So it's very important to distinguish between the area of a rectangle and that of a triangle. We all know that in the case of a, in fact, in the case of a rectangle, the area is given by the formula A is equal to length times breadth. So that is one aspect of the area of the rectangle. But there's a difference between the area, how we calculate the area of a rectangle and how we calculate the area of a triangle. There's a huge difference. There is a huge difference, and I want us to look at the difference. And we have probably done this at some point. I'm just demonstrating to everyone now that the area of a triangle is half of the base multiplied by the height. And this has been proven in a rectangle, you know, that if you take half of the base and you multiply that by the height of the triangle, you should be able to get the area of that triangle, which is different, by the way, from the area of a rectangle. So, first things first, we are continuing now. I've shown you how to calculate the area. In fact, I've given you the formula. So you can use that formula to find the area. So the formula is A is equal to half of the base multiplied by the height. So half of the base multiplied by the height. And remember that we are given the base. We are given the base, and the base is 6 centimeters. The base is 6 centimeters, and the height is 10 centimeters. The base is 6 centimeters, and the height is 10. So we can be able to use that just to calculate the area. So I see that Lizanne has already done so using the equation. And Lizanne McEwan says the area is 30 square centimeters, and this is supported by Cesar. Thank you very much indeed. Those are the two learners who got it right. I fully agree with you. This will be 30 square centimeters because half of the base, remember we said that the base is 6 centimeters, and then we also said the height is 10. So basically what you need to do in this case is to just substitute. And you'll have half of 6 times 10. And half of 6, as we know, is 3. So half of 6 is 3. Then you'll have 3 multiplied by 10, which is equal to 30. So basically, 30 will be the correct answer in relation to the area. So when we calculate the area of this particular triangle, then we'll get 30 square centimeters. Thank you very much indeed, Cesar, as well as Lizanne. The last one is the perimeter. Can we find a way to calculate the perimeter? And listen, now we have the perimeter of an equilateral triangle. The next one, of course, is, let's see that Mtantla has given her answer as 120. Okay, it's not only Tlantla, also Lizanne. Lizanne says 3 multiplied by 40. And then you got 120. Great, Lizanne. I fully agree with you there. What you are saying there makes a lot of sense. And this is something that I agree with. Remember that we have defined the perimeter as the distance around the edge of the shape. And of course, in this case, we are now proceeding to demonstrate that if you add all of them, all of the sides, you should be able to get our answer, which is the perimeter. So the perimeter there should be given as the distance around the edge of the shape. And in our case, that distance will be 120 centimeters. So basically, that is what we need. That is what we need in relation to this particular perimeter. You just add the 3 sides together and then you are fine. Once you add all the 3 sides, then you have what we call the perimeter. So Amohelang as well, I see you said that 40 times 3. So you multiply 40 by 3 to get 120. And Tlantla says you add 40 and 40 and 40, 3 times there. So remember that multiplication is also a repeated addition. So if you multiply by 3, then you add the same number 3 times. Okay. So if you multiply 40 by 3, for instance, then it's the same as adding 40 by 40 and 40. You add 40 plus 40 plus 40. Then that's the same as 40 times 3. Multiplication, which is a repeated addition. Then, at this point, we have now concluded our 2D faces there. So those are the faces. Remember that in a 3D object, a triangle becomes a face. And therefore, if you know how to calculate the area of just one triangle, it should not be difficult for you to find the total surface area of any 3D object as we are going to proceed. I'm just going to recap now in terms of the 3D shapes. If you have a cube, I just want to check with you, how many faces are there in a cube? How many faces? Right, Ntlantla has answered this to say there are 6 faces, and your answer is supported by Amogelang. So Amogelang also says that there are 6 faces. Now there are 2 students. Up to so far, there are 2 students who agree that a cube will have 6 faces. Great. Now, the key question that emanates from the previous one is that what shape are they, or what type of a shape? Now, Cesar says it will be the square, you see. Great, Cesar, that's the correct answer. So it's very important to characterize your 3D object in terms of the faces. The reason being, every time you need to calculate any surface area, you will definitely need to know how to find the area of the square. So if you don't know how to calculate the area of just one square, then it will be difficult for you to calculate the area or the surface area of the entire cube, because a cube consists of 6 squares. And I'm sure you'll agree with me that when you calculate the area of any cube, it is sufficient to calculate the area of just one square. And then you multiply that by 6, because there are 6 squares in a cube. Great. I see that Cesar has said it's a square. Now, we can't draw them now. Let's skip the drawing part. Let's go now to naming the 3D shapes which can be formed out of the nets that are found here in the center here. I've got 2 nets. And I want you to tell me, what are those objects that can be found or drawn, rather, or constructed, since they are 3D objects? What are those nets going to do? So the 3D shapes that can be formed out of these nets. I see that Cesar is the only one up to so far saying the square. You say we can form the square. All right. Oh, the square was the previous answer. You say now the rectangular prism as well as a cylinder. Great. So you can actually, Amogelang agrees as well that the second one, you can form a cylinder. Yes, I fully agree with you. Amogelang, a cylinder can be formed. If you look at the nets consisting of 2 circles there and a rectangle, and the first one being the rectangles, you can use those just to find or construct a rectangular prism. Now, I want to check once again your understanding. We have done this concept of a triangular prism. How many faces are there? How many faces are there in a triangular prism? How many faces? Somebody says 8, another one says, I see brother says 5, Rizan says 8, and Tanta says 5, Musa says 6, Daniel says 5, and then Amoelan says 6. Right, that's okay, Lisette says 6. Now remember the triangular prism. I've just shown it to you not long ago. Please have a look at this triangular prism thoroughly. and be in a position to check or tell me how many faces are there. In order for you to classify your, or rather, Simonsa says, sorry, there is 5. I'm glad that you can see that now. So the basic thing that you need to do is to classify, for instance, how many triangles are there. So Lizanne also agrees. Lizanne McEwan, thank you very much. So just as I was saying, the basic thing that needs to be done here is to check how many triangles are there in the 3D object. And lastly, how many rectangles. So you can see that we basically have 2 triangles which form the 2 faces. And then you have got the bottom rectangle. And on the sides, the 2 sides, you have 2 equal rectangles. So basically you'll have 5. You'll have 5 faces of the triangular prism. So basically you will have 5. And this is what we have. We have about 5. All right. And then perhaps the next question should be, what shape are they? Or what are the different shapes of the faces? And I've already given you the hint. All right, I see what you see, Musa. The rectangular prism will be much more different. Right, in this instance, now that we know it's a triangular prism that we're talking about, what are the different shapes that make up the different faces of your triangular prism? I have just spoken about the 2 faces and the 3 faces. What are those in a triangular prism? 2 of the faces, okay, you say triangles, great. But how many triangles are there, Musa? How many triangles did you see in the triangular prism? Exactly, 2 triangles, great. Lesedi also continues to agree with Musa to say there are 2 triangles and 3 rectangles, great. Brother says there are 2. I hope you are talking about 2 triangles and then there are 3 rectangles. Thank you very much indeed, Musa. And brother as well saying there are 3 rectangles. So those are some of the properties of a 3D shape, which is known as a triangular prism. So we should not be able to struggle. Now, I wanted us to look at this. This you can do at your own time. Please make use of this worksheet just to answer the questions that follow. You can see that we have got different shapes. At the top there, you can see our triangular prism is there in the middle, top middle, and you can ask yourself questions, how many faces are there? We've already answered that there are 5. How many vertices? And then how many edges? So you should be able to practice using that particular worksheet. And of course, just to wrap up once again the lesson, we have spoken about the polyhedron, which is the 3D object. And you can tell that it's a 3D because of the vertices, the edges, as well as the faces. Always remember that in any cube, there will always be 6 of those faces. Yesterday, I also gave you the example of a microwave or a box of matches, which can be utilized. So there are many different examples that you can think of when it comes to a 3D object. And of course, the cuboid being one of those, together with a cube being the 3D object there. And of course, the cone, the sphere. But at the same time, if you look at this property sheet, you can be able to link the correct 3D object to the statement that is given on the left. So just look at the statement. If you look at the first row, we say that one of these 3D objects has got 8 faces and then 18 edges and 12 vertices. Is it a sphere? Is it a pentagonal prism? Is it a hexagonal prism? So you have got 3 options to choose from. Faces, there are 8 faces, 18 edges, and 12 vertices. Now the key question that must be answered, is this a sphere? Are these the properties of a pentagonal prism, or are these the properties of a hexagonal prism? I hope that you will take the time and the trouble to answer those questions. So you can tell without doubt that the 3D object, which has got 8 faces in this case, will be the hexagonal prism. So the last one, the top right, that will be the last one. Yes, I see Musa also found the hexagonal prism to be the correct answer there. And then if you look at the second one, there are 5 faces and then 8 edges and 5 vertices. Now, if you look at the 3 objects there, we have the square-based pyramid, which is in the center. We also have the triangular prism. Now, in order to tell whether we're talking about one of these 2, you can see all of them have got 5 faces. Remember, we said a triangular prism has got 5 faces. Even a square-based pyramid will have 5 faces. But the answer in this case, as Musa is saying, will be the square-based pyramid. Why? Because we look now at the vertices. There are only 5 vertices in a square-based pyramid. But when it comes to the triangular prism, there are 6 vertices, as you can see. So it can be the property of a triangular prism. And then you go to the next one, you can see 6 faces, 12 edges, and then 8 vertices. Which one is it going to be? Rectangular prism, yes. Cesar correctly stated it is the rectangular prism, the middle one. Great. The next one, 7 faces, 15 edges, and 10 vertices. This should also not be a problem, especially because we can tell without doubt that the pentagonal prism. Great. Musa has answered that. The pentagonal prism, that will be the correct answer. And the last one, where there are now 7 faces and then 12 edges and then 7 vertices. Which one is it going to be? Is it the cube? Can be the cube. Is it the pentagonal prism? It can be, because the pentagonal prism has got 15 edges and then 10 vertices. So obviously there has to be a pentagonal pyramid, not the prism. It's a pentagonal pyramid. All right. So this basically brings us to the end of our lesson. And once again, we have looked at the Pentagonal Prism as well as the Hexagonal Pyramid and those properties. Let's carry on with the lesson tomorrow. Please do the homework that I gave you. And of course, don't forget to email the Miss Piri there, Miss Taylor, sorry, Pilisiwe Taylor, just to give her your different answer sheets. Until we meet again tomorrow, once again, the lesson was brought to you by the STEM Digital School in partnership with Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.